Hi class, we continue our study in chapter 7 talking about similarity by moving into section 7.2, and this is proportion, properties, and problem solving. So in the first part of this lecture we'll introduce some properties. All right, that's our first objective here, is we want to use properties of proportion to write equivalent proportions. So just basically rewriting proportions. And then the second thing we want to do is we want to do the problem solving. So we want to solve problems by writing proportions of some type. Okay, so let's talk about the three properties of proportions. So if you have these variables a, b, c, and d, and they do not equal 0, none of them, right? We have this first property. If you have a to b is equal to c to d, well, that's equivalent to b to a is equal to b to c. So really it's just the reciprocal or flip of the proportions are equal. So how we apply it, so we have the reciprocal of each proportion. So if we have 2 to 3 is equal to 4 to 6, well, that becomes, by flipping it, 3 to 2 is equal to 6 to 4. You're just flipping each fraction. Equivalently over here, another one, if you have a to b is equal to c to d, well, that is equivalent to a to c is equal to b to d. So all you're doing here is you're switching the means of the proportion, right? So basically 2 to 3 is equal to 4 to 6 becomes 2 to 4 by switching the means is equivalent to or equal to 3 to 6. All right, finally, if you have a to b is equal to c to d, it's equivalent to a plus b to b is equal to c plus d to d. So in each ratio, what you're doing is you add the denominator to the numerator. So if you have 2 to 3 is equal to 4 to 6, it's an equivalent statement to say 2 plus 3 to 3 is equal to 4 plus 6 to 6. Or another way is 5 to 3 is equivalent to 10 to 6. Okay, keep these three in mind here because we're going to use them in the next section or next example. All right, so we want to use these properties of proportion to write three proportions equivalent to the following. 3 to x is equal to 4 to y, or 3 over x is equal to 4 over y. So property 1, so let's write the reciprocal of each ratio. So if I have 3 to x is equal to 4 to y, by flipping them, flipping each fraction, x to 3 is equal to or equivalent to y to 4. Same exact proportion, okay? Just rewriting it. They're both equivalent proportions. The second one, let's switch the means. So if I have 3 to x is equal to 4 to y, the x and the 4 are going to get switched here. So we just go whoop, like this. They switched. And an equivalent proportion is 3 to 4 is equal to x to y. Finally, the third one in each ratio, let's add the denominator to the numerator. So I'm going to take the x and add it up here. I'm going to take the y and add it up here. So an equivalent one is 3 plus x to x is equivalent to 4 plus y to y. All right, so let's talk about this one. So in the diagram over here, the ratio of x to 6 is equal to the ratio of y to 7. What ratio completes the equivalent proportion x to y is equal to what? Let's justify our answer. All right, well, first notice the positions of x and y in the first proportion. Now see where x and y appear in the second proportion. So over here, where do they appear? So the y just got transported down to here to replace the 6. So we're going to use property 2 here. Right? We're going to flip the x and the y, or excuse me, the 6 and the y here. And the equivalent proportion of x to y, well, that's equivalent to or equal to 6 over 7, or 6 to 7. Another way you could do this is using cross products. So take my original proportion, cross product it, so x times 6, 6 times y. Then what you're going to do is you're going to divide both sides by 7. So the 7 cancels here, like this. And you're going to divide both sides also by y to bring the y over. And then the 7's cancel here, the y's cancel here. And you get the x to y is equivalent to 6 to 7. Another way you could solve it. All right, let's do a couple problem-solving examples here. So these are just some different word problems. So on a Chamber of Commerce maps of Abita Springs, 5 miles corresponds to 2 inches, okay? How many miles then is 7 inches? All right, well, let's see how we would solve this. So the first thing you want to do is you want to understand it. So you want to read and reread the problem. You may want to draw a diagram. So by drawing a diagram here, what I mean is all right, every 2 inches is 5 miles. So I know right off the bat that 6 inches, well, that's 5, 5, 5 is 15 miles. So I have something here, all right? Well, the total is between 15 and 20 miles here, so it's going to be somewhere in here. So from the diagram, we can see that a reasonable solution is going to be something between 15 and 20 miles. We just have to figure out exactly what that is. So the next thing we're going to do is we're going to translate this. So we'll let x be some unknown number. Since 5 miles corresponds to 2 inches, and that would mean that x miles, what we're looking, corresponds to 7 inches, we have a proportion. So miles to inches, 5 miles to 2 inches, is equivalent to, I don't know how many miles to 7 inches. Well, here, just solve this proportion. You're going to use the cross product here. So 5 times 7 is equal to 2 times x. 35 is equal to 2x. Divide both sides by 2. And you get 17.5 or 17.5 is equal to x. So interpret, let's check your work. All right, this result is reasonable and fits our estimate since it's between 15 and 20 miles. So let's state our conclusion that 7 inches does indeed correspond to 17.5 miles. All right, let's do another one. The standard dose of an antibiotic is 4 cc's or cubic centimeters for every 25 pounds of body weight. At this rate, find the standard dose for someone who's a 140-pound woman. All right, so first thing we're going to do is we're going to understand. All right, we're going to read and reread the problem here, and you may want to draw a diagram. So we know the ratio here is 4 cc's to 25 pounds. And I know the person is 140 pounds, so I want to find the cc's here. All right, so we can see here with the diagram, take a 140-pound woman, 25, 25, that's 100 pounds, 125 pounds, 4, 8, 12, 16, 20, all right? So it's going to be something, I think, over 20 cc's here. All right, so an estimate is a little over 20 cc's, a reasonable estimate here. So to translate, we'll let x be the unknown number. The written example, we know 4 cc's is to 25 pounds as x cc's is to 140 pounds, or, forgive this typo here, this should be pounds, not points. So 4 cc's to 25 pounds is equal to x cc's over 140 pounds. So we just have to solve this proportion. Cross multiply here, 4 times 140 is equal to 25x, or 560 is equal to 25x. Divide both sides by 25, and you get 22 and 2/5, or 22.4 is equal to x when you plug that into your calculator. So this, let's check this. This result is reasonable since it's a little over 20 cc's, like we said. So our conclusion is the standard dose for a 140-pound woman is 22.4 cc's.